Okay, just had to get a second here to grab something else real quick. All right, I'm meteorologist Aaron Tuttle here with you, and it looks like a couple thousand of you are jumping on here real quick. We've got a threat of severe weather to talk about for Tuesday. Earlier, let's see, several days ago, a storm system was coming in, like it was going to move across Nebraska and Kansas, and Oklahoma would get dry slotted, meaning a southwest wind, and we wouldn't get much storms, with the exception of far eastern Oklahoma. Well, it looks like the models have shifted that storm system south a hair, and it has brought central Oklahoma into the mix and still points out to the east. So basically, roughly right along I-35 and points eastward is where the severe weather potential for tomorrow resides. So you know me, I like to get right down into details, so I try to make this as quick as possible. I know it's getting late. I had to wait for the latest computer model data to come in, so that took a while. About 9:30 is when all that stuff kind of finalizes over the next 24 hours. So I want to make sure I had the latest for you to inform you. Okay, so let's go ahead and get to the maps. So this is the upper level storm system out here. That'll be anchored across the Oklahoma Panhandle. So this activity will be moving on off to the east. And as this storm system makes its way eastbound, it'll help to trigger showers and storms again all across the eastern half of the state. Now, they'll be scattered in nature, so it won't be a widespread event, but where the moisture pools and where the best instability resides, that is where you're going to get your action. Now, we have the mid-level lift as far as what that particular storm system goes. We also have a upper-level jet streak. Now, this is what we're going to call the exit region of the jet. So this is going to be, where's my little drawing deal here? Okay, so right in this area here is the ideal location to exhaust the atmosphere aloft. In other words, just to let all that air come rushing out at 15, 20,000 feet or so. And that helps to kind of think of it like a vacuum cleaner. It helps to pull that air upwards, and then it helps to provide some really strong thunderstorms. So the ideal position for severe weather is there as far as that feature is concerned. And we also have a mid-level jet streak. This is at 500 millibars. And these values here, I don't know if you can see on the map here, about 79, 80 knots. So this particular enhancement of wind rotating around the bottom end of this upper low late tomorrow afternoon is going to be working its way into central Oklahoma. So this jives with the timing of the surface features. So a couple of things are coming into play here, ideally for a setup of severe weather. Now the question is, of course, always, where's the moisture? And you know me, for the last couple of systems, I've kind of poo-pooed them for the most part just because we haven't had really significant dew point values, and we really need those to produce a good chance for tornadoes. Now this time around, I'm still going with that, but it's going to be a hair different, and I'll explain that here in a minute. Let me go into a closer view here. Let's see. Switch sources. Okay, so what we care about here is going to be the dew point values. And I've got this map stopped at about 4 o'clock in the afternoon. So this is what's going to happen. So you're going to have this low pressure system down here across the Red River come northeastward along the I-44 corridor. And it's going to come right here in central Oklahoma, right in Oklahoma County by 4 o'clock. So what that means is, from this surface low, you get a warm front that trails off to the east-northeast. You get a pseudo-cold front that's back behind it. And then you get the dry line that extends on out from the low down to the south and west. So these areas of enhanced features is where you typically get storms. So sometimes they're on the dry line, and then also along the warm front, as long as it's uncapped. In other words, there's not a lid or an inversion to prevent storms from developing. But you have all this air that rushes into this area of low pressure at the surface. So remember, you got low pressure coming in the bottom, and then you have all that vacuuming coming out from the top. So typically in a situation like this, you get severe storms, and with the fact you get all these winds turning with height from the surface all the way up, the enhancement is there for tornadoes. So that's why today, when I was looking at the data, it kept suggesting this low was coming in here, and I was like, I don't like to see that, especially over Oklahoma City Metro. And I'm like, all right, well, we'll see what it does. Well, the evening models continue that trend. Now, here's the kicker, though. Does it produce storms in time? Now, not all models are going to agree on this. Again, this is 4 o'clock, and it's got nothing here except for maybe a couple of showers starting to develop in Oklahoma County. If we go to the 7 o'clock hour, it already has a line of broken storms stretching from Tulsa in northeast Oklahoma down, say, west McAllister and on the southern southeastern Oklahoma. So that is a quick change from nothing to a line of broken storms. So what that tells me, right after 4 o'clock, the models think that's ideal for things to just explode from nothing to severe weather. And again, that's going to be very close here to the metro. So close that you might as well go ahead and plan that they will be developing here in town, but then quickly moving off to the east-northeast, because they'll be moving away probably about 35, maybe 40 miles per hour. So it'll be pretty fast movers. And that's good. They won't be around any length of time. Now, let me show you something else. So this is the high-res model that we typically use for short-term, extended outward in time. And I want to show you it also has an area of low pressure right here over central Oklahoma. Now, it's not quite as far north as this other model. It's actually down in maybe say anchored toward Cleveland County. So it all depends on where this exact feature lines up during the max heating of the day. And you get the, in other words, in that upper level features come in. So again, all the timing is key here as to where you're going to get the severe weather initiated. And so that's why Oklahoma City is just right there on the fence. The other thing is, with this particular model, it does produce severe storms here across the metro. So you can see right here, this is Oklahoma County, Canadian County, down toward Newcastle, and Blaine, and you've even got Cleveland, and up even north a little bit toward Logan County. So it does produce enough lift here to get some severe weather right here in Oklahoma City. And that would be severe hail, damaging winds, and yes, a possibility of a tornado or two. And then that would continue as those storms move off to the east. Now, you need CAPE, which is the instability we talked about. So here's 4 o'clock in the afternoon. You've got some yellow in here, which is CAPE of around 2,000 joules. That's plenty. Now, the key is here, and this is another view of the radar, how it kind of goes from just some spotty showers around 4 o'clock to, there you go, some severe storms at 5. But notice how it's east of I-35. And then they continue to bubble up and move off to the east by 6 and 7 o'clock. Now, again, I don't want to sit there and go, yep, that's going to be plenty far away from the metro, no threat here. I'm not going to bother the model to that degree. The other issue, as we talked about, let's see here when I show you, with the pooling of the moisture, the dew point values in, let me show this real quick. You can see these values here are right around 60, 61, 62, just on the east side of the metro, stretching up the turnpike toward Tulsa. So the ideal sweet spot corridor, if you will, for tornadic development is going to be along that warm front just northeast of the surface low. So that's going to be in this area right here. So that's Oklahoma City, up the turnpike, right into Tulsa. Now that's the way the model data looks right now. And if there's going to be a tornado, that is the most favorable location due to the ingredients in the atmosphere. Now that's not a guarantee it's going to happen. I'm just saying that's the most likely area. Now, here is a look at what the model considers a significant tornado threat. Now, it's not that high on the scale, but you can see it jives with what I'm telling you, where the dew point values are maximized along the warm front on into Tulsa. And again, that's Oklahoma City, really stretches down around Newcastle, then back up into the west sides of Tulsa. So that's a significant tornado threat. And let me animate this to see. This is 5 o'clock. See, so 5 o'clock, 6 o'clock. 7 o'clock, so that little enhanced area moves off to the east along with the storm. So the threat here in Oklahoma City is very short-lived, 4 to 6 o'clock at most, and it's out of here. That's it. So if it doesn't happen in that time window, it's already going to be off to our east. Now the supercell threat, which is you need a supercell storm to produce this type of a tornado. And as we look at the 4 o'clock hour, you can see the model is way more excited about a supercell threat in this area. In other words, it's a lot more excited about supercells than it is about tornadoes. That doesn't necessarily mean much, just saying that if you're going to have a supercell in this environment, due to the other ingredients I showed you, odds are pretty good you're going to get a tornado out of it at some point. Now, that's not to say it's going to be a long-lived or very strong tornado. I'm not going to get into any of that right now. Tomorrow morning, we'll have better data, and then we'll be able to tell you as to whether or not the strength potential of some of these and if they can last very long. It all depends on the wind shear in the atmosphere at different levels as to whether or not how significant that threat's going to be. But I'm telling you now, tonight, and I kind of alluded to it earlier this afternoon, the threat there is going to be for some supercell storms, pretty much from Oklahoma City, stretching up toward the Tulsa area. And that's just the most favorable region. Not to say you can't get a couple outside of that little box, say especially down, say 69 from Tulsa southward toward McAllister, and then the eastern Oklahoma. There could be a couple more in that area. But as far as the wind shear in the atmosphere that would be capable of producing a tornado, it's most favorable along that warm front boundary. And right now it looks like that warm front boundary is going to be anchored pretty close to 44. Now, this is all a caveat because let's say that surface low doesn't quite make it to the metro. Let's say it stops south end of town. Well, that shifts the warm front down south as well, which makes it south of Tulsa. So in other words, Tulsa is no longer in that type of a threat. Maybe it's down toward McAllister. These are the fine details that you cannot ascertain this far out. You can get an idea and a general location and a general concern region, but once you get into the morning data, and then every hour after that, it becomes a more mesoscale forecast, which means a short-term looking at the surface features to detect where the most likely area is for severe weather. So I do expect the Storm Prediction Center to up their risk of storms and shift it back to the west. Earlier, they just had us in a marginal risk of storms, and then later today they put us in a slight risk. I want to point that out to you because it goes to show you you don't have to talk about a threat of tornadoes 10 days from now. It's pointless. There's times to where it doesn't like a big event, and then all of a sudden the day before you're like, well, wait a minute, models are finally catching on that this storm's a little bit stronger, it's coming in a different track, and now we've got better shear, we've got better this and better that. All right, now we have a better shot of severe weather. So some of these events are 24-hour events. Sometimes we can tell you within 48 hours on the details such as this, but that's why I caution you not to get too worried about anything beyond 48 hours. Too much can change one way or another. And even tomorrow, I could look at the morning data and things may not be nearly as concerning as they are now. Now, just because I say they're concerning, that's for me as a meteorologist. All you need to do is just have a game plan that you already have. So when you're talking about severe weather in spring in Oklahoma, you're going to be fine. There's no need to panic. There's no need for anxiety. There's no need just to worry and leave town. It's not that type of a situation. Remember, we get thunderstorms around here all the time. Little hail, little wind. It's not that big of a deal. Tornadoes, yes, I understand that's a concern. The good news is for those, we only average 56 tornadoes a year in Oklahoma. That's covering the entire state. And they're like needles in a haystack. So they affect very few amount of people, which is the good news. And you can also survive the majority of tornadoes as long as you put as many walls between you and the outside as possible. If you plan ahead, and when you get a warning, or say you use my weather app and it tells you before the tornado warning comes out, say it says twisting storm approaching. That basically means that the algorithms in that app is telling you that as far as what it's concerned, when it compares the radar data, high-risk short-term modeling, climatology, analogs, kind of all rolled into one, it says, okay, this environment is favorable for this particular storm to produce a tornado at any moment, so be ready. Okay, so it sends you that information, and now you have up to 20 extra minutes to act based off of that. That means more time to get things down the shelter, more time to round up the kids and the pets and all that stuff. And then typically a tornado warning officially comes out from the National Weather Service. So it gives you a few extra minutes, which I think is very valuable. So try it out, AT's Weather to Go. It's free, and it could save your life. In this particular case, like I said, the center part of your home is where you want to be. If you got a storm shelter, great. Indoors, outdoors, it doesn't matter. Some question as to whether or not which ones are better than others. As long as you've got one, use it. If your friends and neighbors have one, use it. If you're going to build one, just make sure that the company is not scrupulous and that they build it according to FEMA guidelines. There is no FEMA approved shelter, but there are FEMA guidelines as to which they should be built by. If you want to go above ground, that's fine. Just make sure it's going to be very noisy. You want to make sure you have earplugs, gun range earphones, that kind of deal. Headphones, rather, to kind of block out that noise. It'll be a little quieter in the underground ones. And they can be in your garage, they can be in your yard, whichever you want to do. If you're asking me what my preference is, any shelter will do. There's some pluses and minuses to whichever kind you want. It's really all a personal preference. And as I said, you don't even have to have a shelter to survive a tornado. The majority, let's see, I'm thinking roughly 80% of tornadoes is EF2 or less. All of those easily survivable and adequate shelter as long as you're in the middle part of that feature. If you're in a mobile home, get out. Just don't be there. That's not going to provide you anything, even for an EF0. Go find a neighbor. Go find a building. Any building will do at that point. Here's another thing. If it comes out to a case, we've got tornadoes tomorrow afternoon here in the metro, or they're about to form, or whatever, don't get in your car and leave anywhere. Do not do that. A, it's going to clog up the roads. B, now you're going to be stuck in traffic with everybody else. And if there is a tornado, now you got nowhere to go. If you are in a case where you didn't leave, maybe you're all coming home from work. Again, this is going to be close to drive time, so this is possible. You got to get to a building. If it's a case to where you absolutely have no building at all and no time reaction at all, you have two choices. You're going to need prayer in either one, but one is just strap your seatbelt on and hang on. The second one is get into a ditch. Now, after typically a tornado passes by, that's the first thing you'll see before the heavy rain moves in. So there is a potential for some flooding in that culvert or ditch. So you're going to have to act and move quickly. Once it's gone, just get moving. But again, that is the absolutely worst case scenario. It's best to find any type of building, whatever you can find nearby. Remember, desperate times calls for desperate measures. It's fight or flight. It's survival of the fittest, that kind of deal. Do not, though, get under an overpass and clog up all the highways. A, you're not safe. That's the first mistake. 2, you just blocked all the emergency responders. You blocked all your friends, families, neighbors, whoever else is trying to escape and save their own life. You don't be responsible for that. I wouldn't want to be able to sleep at night with that on my shoulder or my conscience. So don't do that either. Just go find a building somewhere and get inside. And again, stay away from windows. The most center part will be fine. So those are a lot of tips you can use. As far as a shelter is concerned, if you don't have a bug out bag or kit, grab one, get one at night. Get the helmets, for the kids, for the sports. You can throw flashlights in there, your medication, some cash if you want it. The big thing is clothing. You're going to want clothing as far as tennis shoes go, because if for whatever reason you do come across some damage in your area and you're walking around with that stuff, you can get a lot of nails and you're going to have to get a tetanus shot, that kind of deal. And that's usually actually the most common injury after a tornado, believe it or not. There are cases where we have large tornadoes and the structures are wiped away and the people still survive. And that's probably because of physics. Once you become part of the tornado, you're not getting hit by the debris. You're actually within the debris path until you get settled down somewhere. And I really think that's how a lot of people do survive the tornado. Rather, as if you're a fixed target outside of that entity getting hit by debris, that's where it's harder to survive. So I think that's how, even a lot of times when you don't have a shelter and you're in a building, you have the absolute worst type of tornado, which is the strongest EF5. You get wind speeds up around 300 miles per hour. Several do survive just because I think of that fact alone. And it's a good thing that people can still survive even at that level, because those winds are pretty ferocious. But keep in mind, majority of tornadoes are on the weak side. And so this is a situation where don't need to panic. I think there'll be a couple of severe storms. I think there'll be supercells. And yes, I think there'll probably be a couple of tornadoes. And it'll be close to Oklahoma City Metro and then points northeast along 44 into Tulsa, assuming, again, everything pans out like the model data has it for tonight. And that's not saying much because that can easily change, and so we can fine tune in the morning. All right, so I'm going to put this, I'll leave this up on Facebook Live, kind of a little longer than I anticipated, but I gave the front end of the forecast very quickly so you knew what was going on. And the latter half, I kind of talked about tornadoes itself and safety and what you should do and not do. So it's kind of a double deal here for you for information. All right, guys, well, I will be watching it for you tomorrow. And if it looks like tornadoes are a possibility, I will be covering in live severe weather coverage. You can watch that through my app, through my website, AaronTuttleWeather.com. And I'm also trying to simulcast as well on Facebook Live. So make sure you get notifications on my Facebook page. Just go up to the top where it says get notifications and make sure you're subscribed to that so you'll be notified when I do go live. And make sure you share it with your friends and family and everyone. I've had three weather events that I've gone to in the last few weeks. And every time the common denominator that I've heard was, thank you for anxiety-free storm coverage. Because the TV stations have gotten everybody so worked up to where they fear every time it rains. And I understand that because I used to be part of that business. I do provide a much more low-key, anxiety-free type of storm coverage. I approach it scientifically. I just tell you what I see, what it's going to do, where it's going to go, who it's going to affect. It's very basic, very simple. I've got a storm chase crew out. They'll be out in the vicinity if they're out near a storm. We'll pull in their live video just to see. But I'll be running radar, putting storm tracks up, that kind of deal. So that's what I do here as part of AT's weather. So my goal here is to keep you safe and get you through the storms during the spring season. So I want to thank you for watching tonight, and we'll check in with you again tomorrow. Talk soon.